read through this problem on your own. So basically, here's Earth, Mars, and the distance here is going to be 466 million miles. And I'd like to write that as a scientific notation deal. So here's 4.66 times 10 to the power of 8. And that's basically because there are 1, 2, 3, 4, 5, 6, 7, 8 digits after 4.6 where I would sneak that. And the whole travel is miles, so this is going to be in miles. And this route took it 200 days. So 200 days to accomplish that. Now that would be the rate of change, the miles per days. But the question wants to know what the average speed of the vehicle is. So the spacecraft is going to be measured in miles per hour. So the issue is we were given days, and we didn't know how many hours that would be. Well, we only really need one conversion factor. And we know that there are a certain number of days for a certain number of hours. And really, we'd erase that S because it's just one day is equal to 24 hours. And the reason we chose this is so that the days were up top and they would cancel out, and my units that I'm going to be left with would be miles per hour. So let's say you had made a mistake and you had originally written 24 hours per one day. You'd be like, well, these don't cancel out because they're both in the denominator. And so the units that we're left with are going to end up being miles per hour. So we're finished, and nothing here really cancels all that nicely. So get a calculator out and take care of it that way. Making sure that you keep this in the numerator. And if you were to divide by 200, you'd probably want to do divided by 200 times 24 in parentheses to make sure that both of those end up in the denominator of the fraction. Or you could just divide it by 200, but make sure you then divide it again by 24. Whatever's the clearest to you, and this is where it's nice to use Wolfram Alpha or something, or a graphing calculator that displays what you typed in. So when I typed this in, I got 97,083. And it would be like 0.333. And if you wanted to keep that totally accurate, it would be approximate. And if you wanted to keep that in scientific notation, you could just be like, well, 9.7 times 10 to the third miles per hour. Either of those is A-OK. Let's check the next problem out. Go ahead and read through this on your own. Okay, make this one an on-your-own problem. And when you read through it, I guess the only hiccup you might have is the same distance. So remember this from the problem before. And my hint on figuring out how long the trip took is that's the launch date, and that's where it ended. So you could figure out how many days passed from then to then. And if you wanted to, you could actually type those dates into Wolfram Alpha and figure out how far apart they were. And this would be the assignment that goes along with it.